Yeah, so we're going to talk about design philosophies today. So these are the three design philosophies that we'll be looking into when we want to design a structure. The first one is working stress method. The second one is ultimate load method. Third one is limit state. Now let's see what working stress method is all about. This was the traditional method used for reinforced concrete as well as structural steel and timber design. The working stress method assumed that the structural material behaves in linear elastic manner and the stresses induced are in permissible limits. That means the stress and strain was proportional to each other throughout according to working stress method. The ratio of the strength of the material to the permissible stress is known as factor of safety, and factor of safety was used here for finding in case of the to find the point loads of the material. Factor of safety was used in the case of working stress method. Here the strain of the concrete is compatible with the strain of the steel. That's why that's the same assumption that the material used behaves in linear elasticity, that is stress is proportional to strain throughout. And also another concept is also introduced here, that is modular ratio, which is the ratio of moduli of steel to that of concrete, which will get us 280 by 3 into sigma CBC. Now this working stress method had a lot of limitations. The first limitation was that linear elastic behavior throughout is unrealistic. Obviously, by the we see the stress strain relationship of steel and concrete, we'll say that only till the elastic limit it is stress and strain is proportional, but after that it starts varying. When stress decreases, strain increases, still increases abnormally. The second assumption was uncertainties of different types of load were not well defined. That is, the say for uniformly distributed load, self weight, etc. They were not well defined in this method, and the difference between dead load and live load was not mentioned clearly. Dead load means the self weight of the material used, and live load that the load imposed on the material. And here a certain constant factor of safety was used, so the it was also a limitation of this method that different factor of safety is not taken into consideration, and it does not account the possibility of overloading. Now let's look into the next philosophy. Oh, and one more thing, modular ratio was not constant due to creep. Next is the ultimate load method. It is also known as load factor method. Here the stress condition at the site of impending collapse of the structure is analyzed. That is the after the stress and strain proportional part, there's part where the strain keeps on increasing. Right? Ultimate load method focuses on that part. The like I said, the non-linear stress strain curves of concrete and steel are taken into consideration here. It is based on different types of load factors. In working stress method, we use factor of safety. In ultimate load method, we use load factor. Here, load factor is defined by ultimate load by working load. It is more economical in design for beams and for beams and columns. Now, next is the limitations of ultimate load method. It gives very thin sections which lead to excessive deformations and cracking. It does not use a factor of safety of material stresses. Next is the limit state method. Limit state method is quite better than the other two and more economical than the other two design philosophies. Now, what is a limit state? It is a state of impending failure beyond which a structure ceases to perform its intended function satisfactorily in terms of either safety or serviceability. That means a particular limit which indicates the failure of that structure. That's what, so that we'll know the structure is about to fail when we, so that we can only impose a particular load on it. Now there are two types of limit state. One is limit state of collapse and limit state of serviceability. Limit state of collapse. It is also known as ultimate limit states. It deals with strength, overturning, sliding, buckling, fatigue, fracture. Next is limit state of serviceability. It deals with discomfort or malfunction caused by excessive deflection, crack width, vibration leakage, and also loss of durability. So that was all about for today about in this video. I hope you've understood what I've explained. With that, I would like to conclude. Thank you.